G'day lads and ladies, and welcome to this week's episode of What's Up Mate, where everything is live, including the conversations. This podcast is aimed at electricians and refrigeration technicians living and working in Australia. But if you're listening in from elsewhere, you're welcome to come along for the journey. The aim of this podcast is to provide extra learning resources for apprentices and tradespeople to help fill a void in our industry, which I have discovered by chatting to industry leaders, apprentices and educators. I hope you learn a few things as well as have a laugh along the way. You're with your host, Jake Sparrow. Now, let's get a conversation going. Hey everybody, Jake here. So, the last few episodes we covered off on Section 1, so Scope, Application and Fundamental Principles in AS 3000. We spoke about Section 2, so General Arrangement, Control and Protection. Section 3, we spoke about in two parts, which of the selection and installation of wiring system. That was pretty heavy, it was about 2 hours worth of content there. So, today we're going to start chatting about Section 4, Selection and Installation of Electrical Equipment. But before we get stuck into that stuff, just like to have a chat. Obviously, we've got the Facebook page, What's Up Mate podcast, as well as the Instagram page. Probably the most direct way you guys and girls can get in contact with me. So if you want to reach out, have a chat, or if you feel like being a guest, like if you think that you have something to offer for the podcast and our listeners, reach out. I'd love to get some industry experts on here as well, so it's not just me having a one-way conversation. So yeah, reach out. So the best way to do that is obviously through our Facebook or our Instagram page at the moment. Also, if you are listening and you like the content, if you could like, subscribe, do whatever you need to do on whatever platform you're listening to us on, that would be brilliant, because it just sort of helps us grow organically and help as many people as we can in the industry. So thank you very much, guys. This week, for myself, it was pretty well refrigeration breakdown all week. It's not even hot yet in Adelaide, but we're starting to see temperatures above sort of 25 degrees, and that's when we're starting to see systems that weren't maintained starting to fall over, which is kind of nice to be able to get the majority of them back up and running before the heat actually hits in, and stock's not getting warm quickly. So some cellars, multiple cellar units, holding in excess of $4 million worth of wine on Tuesday. Monday, I did some commercial kitchen equipment, freezing stock. That was just some faulty evaporator fans. So sorted that all out. Wednesday, that was the day we did the cellar, and that was a long day doing some de-icing of some coils. Just set point set way too low, poor airflows, a heap of issues there, which we've rectified. Thursday, I was doing some maintenance at some cheesecake shops, identified a few dramas, and then Friday went back through and rectified some issues, and had another couple of breakdowns there. The boys, we did some final fixing of some new homes. We did just a full day of just maintenance. I think one of the boys did about 8 jobs, just electrical maintenance, and then Thursday, Friday, started a first fix for a new home up in Mount Barker, quite a large one. It's been a bit of a varied week for everybody. I feel bad I've not actually seen any of my workers except for Monday's toolbox meeting, but it'll be good to catch up with them next week. So yeah, let's get this podcast going. So we're going to move on to Section 4, Selection and Installation of Electrical Equipment. Right, so generally selection and installation of electrical equipment will be done by you as an electrician or maybe an engineer. So we need to have a think about what we're installing, what its intended purposes to do, also its operational safety. So we'll run through all this now. So 412, so we're looking at page 212 in AS NZS 3000 2018. This section basically specifies the minimum requirements for the selection and installation of electrical equipment, including appliances and accessories that shall be achieved to satisfy part 1 of this standard. So again, part 1 is the section 1, so which is your scope, application and fundamental principles. So it tells us what we need to do to ensure an installation is safe. The sections after that, again, is how we go about that. So we need to select electrical equipment to have the following features. So we need to enable the electrical equipment to function properly under external influences to which it is expected to be exposed, prevent any adverse effects that the electrical equipment might cause on the electrical installation, operate safely when properly assembled, installed and connected to supply, ensure there is no danger from electric shock, fire, high temperature or physical injury in the event of reasonably expected conditions of overload, abnormal operation, fault or external influences. And we need to make sure it's installed with the requirements of this section, so section 4, and the additional requirements as specified in the manufacturer's instructions. Now, we always need to make sure we're following manufacturer's instructions because a lot of the time their specific installation requirements are not listed in AS 3000. This requirement, or all those requirements I've just listed, we need to start having a look at external influences and environmental conditions, adverse effects on the electrical installation and the supply, protection against thermal effects, so in overload scenarios we don't want excessive heat being generated to break down that insulation. How we're going to connect the electrical equipment to the supply, installation of socket outlets, lighting and heating equipment, electricity converters including UPS systems, control, overload and over temperature protection of motors, transformers, capacitors, electrical equipment containing liquid dielectrics, smoke and fire detectors. So there's been a few amendments here for these ones which I think we really need to look out. So page 213, 4.73 and 4.17 is the clearance of socket outlets and switches from open cooking surfaces. So an open cooking surface, something like a cooktop, a deep fryer potentially, anything with an open cooking surface. We need to make sure that we don't have electrical equipment installed too close to that, just because heat is an issue, splatter is an issue, all sorts of stuff. We also need to really refer to section 6 if we're going to start installing in like damp areas, baths, pools, spas, that sort of stuff. 413, external influences. So all electrical equipment shall have characteristics appropriate to the conditions to which it is likely to be exposed to ensure that the electrical equipment is able to function properly at the intended point of installation. So suitable design and construction properties of the electrical equipment or additional means provided as part of the electrical installation that do not adversely affect the operation of the electrical equipment to effectively protect against the presence and extent of relevant environmental and other influences. So when we're talking about external influences, they've given us a bit of a list of things which it could include, but it's not limited to. So this is just not an all-inclusive list, I suppose. So we need to have a look at things such as mechanical damage, like whether somebody can kick it, a car can hit it, weather, so including not just rain, so snow, ice, sunlight, so UV radiation can degrade all of our electrical equipment if we don't select it correctly. We need to make sure we've got protection against water, so that includes splashing, spraying, submersion or high humidity. So cool rooms, things like that, like condensation forming within, not so much cool rooms but definitely freezer rooms, condensation forming within electrical equipment inside, or where the cable pathway runs through the cool room. We need to be very mindful of that. Fauna, so we need to look out for things like cattle, like livestock, horses, cats, dogs, anything like that. Geckos could be a good one, especially for like air conditioning installations, stuff like that. Geckos kill a lot of electronics in boards, especially up in Queensland. Excessive dampness, including wet areas and poorly sealed underground cellars. Corrosive fumes, liquids, or polluting substances. So, food industry is pretty big for that one. There's a lot of corrosive stuff within the food industry. Obviously, also a lot of industrial plant and things like that have got corrosive things that we need to worry about. So we need to have a think about those external influences. Galvanic action, so dissimilar metals, accumulation of dust or solid foreign bodies. We've actually spoken about this in section 3. Steam, oil, temperature, temperature including both high and low temperatures. Solar radiation, which we've already listed. Explosive atmospheres, which is often referred to as the hazardous areas. I've not done any hazardous area stuff, so I'm not going to pretend to know anything about that. Vibration and seismic activity. Now, vibration is a pretty common one in industrial scenarios, and we like to use those Wago connectors to sort of overcome that vibration issues, because they're a spring terminal, not a screw terminal, so the springs always maintains that downward pressure on your conductors, whereas a screw terminal with the vibrations can actually become loose. So just little things like that to think about. So we've got a few notes here, some amendments highlighted with the red asterisks. This is on page 214. So solar installs, mainly for the solar boys and girls out there. Obviously, we've got that new anti-condensation and water drains that you guys will install in your conduit work, but it still maintains an IP rating. And it says here specifically that drilling a drain hole in the bottom of the enclosure alone destroys the IP rating of the enclosure. So if you just bung in a water drain with like a 5mm drill bit or something like that, you've actually destroyed that IP rating. So don't do that. So we've got a few exemptions around the degree of protection being IP23 with regards to metering enclosures and overhead line connector boxes. I guess metering enclosures in South Australia is probably the only one that will affect us as electricians. In the eastern states, your overhead line connector boxes need to comply with AS 3124. In SA, we don't get to touch that sort of stuff, like SA Power Networks do that, but I know level 2 Sparkies over on the eastern seaboard, they certainly get to do that sort of stuff. So page 215 gives us a couple of images. So we've got figure 4.1, which will give us an area under an overhang requiring accessories to be a minimum of IP33. So it's a 30-degree angle from your corner of your eave back to the house. So anything that falls within that 30-degree line doesn't need to be IP rated. Anything underneath needs to be IP33 as a minimum. Obviously, that's just the way they figured that the worst case for the rain to be driven in. And then they give us a eave or veranda, same thing. So we've got a area under an overhang requiring accessories to be a minimum of IP33. So this gives you the front view. So if you're not sure of what rating the accessories you're installing need to be, if you're within that 30-degree line, you can just install anything with, it doesn't matter what IP rating you put in. If you put anything below that line, it needs to be greater than IP33. Well, sorry, IP33 and greater. So all electrical equipment shall be selected so that during normal operation, including switching, it will not cause harmful effects to other equipment. Factors that may need to be considered include the following: power factor, excessive voltage fluctuation, distortion of current waveforms, and electromagnetic emissions. We also need to protect against thermal effects. So The selection and installation of electrical equipment shall be such that the temperature characteristics of the electrical equipment, when properly installed and operated, do not adversely affect the electrical equipment, the electrical installation itself, or any other installation, whether electrical or not. So adequate ventilation shall be provided where necessary in order to maintain operating temperatures within the rated or specified limits of the affected equipment if heat is generated during normal operation. So for that, plant equipment, especially refrigeration plant rooms, you'll generally see exhaust fans, and these are either temperature operated or there's like CO2 monitoring, there's refrigerant monitoring, all sorts of things that will enable those fans to operate. So that's just one example of that. Prevention of fire hazard. Pretty obvious we don't want to start fires with anything. So electrical equipment shall not be installed in a position where it might cause a fire hazard. So for batteries, like a few of you guys might know, but I'm also a volunteer firefighter. Batteries are a big concern for the fireys, especially these cheap batteries that are being installed, well not installed, but bought by people for their little bikes, etc. You see Mercedes catching on fires, you see Tesla's catching on fire, so just really have a think about where you're installing these car chargers, I guess. At the end of the day, if the car catches a light and you haven't installed the car, but it might just be worthwhile even thinking about, hey, maybe let's put a thermal alarm or something like that within the garage or something like that if you're installing even a home battery, just to give that prior warning to your clients in the unfortunate event that perhaps their EV's caught a light or it's starting to smoulder, or getting thermal runaway when charging can be pretty scary. Even your thermal batteries, I've seen a few guys installing smoke detectors, but also like fire bombs. They're like little balls that look like red little tennis balls that sit above the battery system. So in the event of a fire, that heats up and it basically drops powder all over that battery or that potential for fire. So have a bit of a think about that. Storage of flammable materials. You just need to make sure that if there's a likelihood that an area will be used to store flammable materials, measures shall be taken to prevent ignition of such materials by sparks or high temperature sources. Just check out clause 7.7 for that. Let's give you some requirements for the hazardous areas. Protection from high temperature. So high surface temperature where fixed electrical equipment could attain surface temperatures that would cause a fire hazard to adjacent materials. The electrical equipment shall be mounted on or within materials that will withstand such temperatures and are of low thermal conductance. So maybe you need to start mounting stuff to fibre cement sheeting. You need to have it screened from combustible building elements by materials that will withstand such temperatures and are of low thermal conductance, or mounted at a sufficient distance away from any material on which such temperatures could have deleterious thermal effects, any means of support being of low thermal conductance so as to allow safe dissipation of heat. High radiant temperatures causing a focus or concentration of heat, it shall be placed at a sufficient distance from any fixed object or building element so that the object or element in normal conditions cannot be subjected to a dangerous temperature. Some building materials can decompose if it's subjected to elevated temperatures for a long period of time. We don't want to do that. Tungsten filament lamps, ELV halogen lamps, radiant heaters, infrared lamps, ballast and transformers are examples of high temperature sources. So there's just a couple of examples. Restriction of heat dissipation from electrical equipment, e.g. by thermal insulation, can result in high temperatures in the electrical equipment itself. So that's why halogen downlights are such a big problem. Obviously they run at, I think, over 300 degrees Celsius is sort of the touch temperature of that. You get bulk thermal insulation on top of that. Obviously that heat can't dissipate and that heat just gets higher and higher and higher and higher. Becomes an issue, but also the transformers got quite warm and they'd actually have the old black big iron core transformers would actually overheat, shut off, they'd cool down, they'd turn back on. Just quite a thing to think of is basically any electrical equipment is going to have some form of heat dissipation, because the reason it's got that heat dissipation is because no electrical equipment is 100% efficient. So that's where that heat comes from, is that efficiency loss. So just have a really big think of that one, and when you're installing your electrical equipment, just make sure that heat can be dissipated. Right, so most electrical equipment, switches, relays, contactors, power points, etc., will emit arcs or sparks. So whenever arcs or sparks may be emitted by permanently connected electrical equipment, in normal service, the electrical equipment shall be totally enclosed in arc-resistant material, screened by arc-resistant material from building elements on which the arcs could have deleterious thermal effects, or mounted at sufficient distance from building elements on which the arcs or sparks could have deleterious thermal effects to allow safe extinction of the arcs or sparks. Deleterious basically means it's going to cause harm or damage. So we want to prevent any form of our equipment that we're installing to cause any harm or damage to building surfaces or buildings or people, etc. So electrical equipment enclosures need to withstand the highest temperature likely to be produced by the electrical equipment. Flammable or readily combustible materials shall not be used for the construction of enclosures. So that's why we can't use timber for meter panels anymore. That's why we're using that black bramite, however you want to say it. Why we can't mount on timber meter panels anymore for installation of electrical equipment if it's existing, because timbers are pretty good. It combusts very easily. It doesn't take a lot of heat to actually get dry timber to combust. Prevention of spread of fire is a pretty big one. Obviously, our equipment might cause a fire. We want it to be contained within the enclosure. So electrical equipment, including switches, socket outlets, and other accessories, shall be arranged to provide a separation of not less than 300 mm horizontally and 600 mm vertically from any opening or recess in the opposite side of a wall, ceiling, or floor that is required to be fire rated, e.g. a fire rated barrier. So firewalls in units, etc. So it's 300 mm horizontally and 600 mm vertically from any opening or recess in the opposite side of a wall, ceiling, or floor that is required to be fire rated. The openings made for electrical equipment installed in fire rated barriers shall not penetrate beyond 50% of the thickness of the barrier. Any gap between electrical equipment and fire rated barrier shall be sealed to the degree of the fire resistance prescribed for the barrier in accordance with the relevant provisions of the National Building Codes. So if we're running cables through a firewall, we need to make sure it's sealed up properly, as per the National Construction Code. Again, if you're not sure, the builder's going to have some pretty good information on that, and if you're the one sealing it back up, you want to be able to comply with their requirements. So protection against burns. So obviously we don't want people getting burnt touching our equipment. So any equipment within arm's reach. So arm's reach is defined in the definitions. So it's any equipment within arm's reach cannot be get a surface temperature in above that specified in table 4.1. So for example, a handheld means of operation, it's non-metallic, it can't get more than 65 degrees. If it's metallic though, and it's handheld, it can't get a temperature in excess of 55 degrees. Parts intended to be touched but not handheld, so metallic 70 degrees and non-metallic is 80 degrees. Parts that need not to be touched for normal operation, metallic 80 degrees or 90 degrees. So obviously elements, things like that in ovens get a lot hotter than that, but they're generally behind a fixed barrier, and they're not intended to be touched. So just a little bit of a thing there, that if you've got any equipment that gets 55 degrees isn't very warm. I reckon some inverters on the sides of people's houses get higher than 55 degrees, to be honest, but again, it's not meant for handheld use, is it? So you can touch it, so they allow up to 70 degrees. So the connection of the electrical equipment. So electrical equipment may be connected to the installation wiring by one of the methods detailed in clause 432 to 435. So regardless of that, all cases, the point of connection to the installation wiring shall be as close as practicable to the electrical equipment, and the connection shall be effectively protected against mechanical damage or interference. So wiring within and forming part of an item of electrical equipment is considered to be equipment wiring. Such wiring shall be in accordance with the relevant product standard, or where no relevant product standard exists, AS NZS 3100. So we've got a couple of examples here. So direct connection. So that's when the installation wiring of the electrical installation shall be directly connected to terminals provided on the electrical equipment for this purpose. So for example, for that would be an oven, a hardwired oven, or a electric storage hot water service. We take our wiring from our fixed wiring straight to that equipment, via whether that's via an isolator or not. Obviously, hot water services will need an isolator. Technically, an oven does not require an isolator because it's not an open cooking service. The other option is an installation coupler, which is an enclosed or unenclosed that meets the requirements of AS NZS 61535, which is a suitable method for the electrical connection of cables, including flexible cords, flexible cables, and rigid, solid, or stranded cables. So wiring from an installation coupler to the electrical equipment is regarded as installation wiring. So we've also then got direct connection by an installation coupler. So where the manufacturer of an item of electrical equipment provides supply terminals for the equipment at a plug designed for connection to an installation coupler, the wiring between the plug and the equipment is regarded as equipment wiring. So see figure 4.5 for that on page 220. So just some amendments to the wiring connected, well, installation wiring connected by an installation coupler. Cords or cables connected by an installation coupler shall be of heavy duty sheath type, complying with AS NZS 3191 and the requirements of 3974 or AS NZS 5000. So we also need to select the cable to suit the protective device. There's an exception there around this sections of installation wiring that terminate within a single piece of electrical equipment, such as a luminaire, single socket outlet, or separated extra low voltage socket outlet. The cable may be reduced to suit the rating of that single piece of electrical equipment. We also want to make sure we adequately protect it and installed to minimise the risk of mechanical damage in accordance with clause 3326. We want to support and fix it in a position in accordance with 3328 and clause 3931, and we want to make sure that that distance to that cable is as short as practicable. Might not always be easy to keep it short, but as short as practicable. So socket outlets. Socket outlets supplied by installation couplers shall meet the following requirements. So this is for like soft wiring, for like office fit out and things like that. Socket outlets supplied by installation couplers shall meet the following requirements. The socket outlet shall be suitable for the intended application and comply with clause 4.4. The socket outlet shall be secured in position and installed in accordance with 4421 and 4422. So when installed in a horizontal surface, socket outlets shall be designed and arranged to prevent the accumulation of dust or water in accordance with clause 154. So horizontal surface, so that just means that the pins or the socket is facing towards the sky, so dust, etc., can accumulate in it if things are not connected to it, which can cause nuisance tripping. I actually had a fault on Friday night that was caused by a power board facing the sky, filled with dust and grime, etc. So where they're installed in a location that is not readily accessible, the socket outlet shall be securely fixed to a structure or support to ensure that no mechanical strain is placed on the installation wiring connections when inserting or removing a plug from socket outlet. So, and that also really comes back to like downlights as well. We want to make sure that we're using cable ties when we fit off our downlight plugs in the roofs to prevent that undue mechanical stress on the cables when we're plugging in, plugging out of our downlights or our fans. We need to also, if we don't do that, we need to actually fit and secure the 413 to the structure in the roof. So a couple of ways around that, obviously. So we've got a few other connection devices. Where wiring terminates to the suitable junction box, sealing rows, or terminating device for the connection of a specific item or items of equipment. The wiring from the connecting device to the electrical equipment is considered to be equipment wiring. So see figure 4.7 for that. So you could probably deem a isolator as the end of your installation wiring, and then between your isolator and your equipment is then equipment wiring. So some air conditioners like Splitties are actually supplied with some 2.5mm ordinary duty flex. You can use that between your isolator and your equipment because it is equipment wiring. So equipment wiring shall be as short as practicable. So a maximum cord length or flexible cord length of 2.5 meters is recommended. We need to make sure it has a current carrying capacity not less than the maximum load of the connected appliance or luminaire. So the minimum cross-sectional area of 0.75 millimeters squared for flexible cord is recommended, other than those specified for portable or handheld appliances and luminaires. So we also need to protect, obviously, the equipment wiring from short circuit in accordance with clause 254. Where earthing is required, be provided with a protective earthing conductor of suitable cross-sectional area that will ensure operation of the circuit protective device in the event of a fault to earth without damage to the protective earthing conductor. So maybe we need to install a slightly larger earthing conductor. Installation wiring connected within a luminaire or passing through a luminaire shall also be selected and erected that the wiring and any associated connections within the luminaire will not suffer damage or deterioration due to heat or UV radiation generated by the luminaire or its lamp. So when I think of any form of lamp that's going to cause that sort of heat, maybe a heat fan light, or we do a fair bit of kitchen equipment, so maybe your heat lamps for your chicken warmers, things like that. They obviously put out quite a bit of heat, but also UV and some infrared as well. So we just need to make sure we're selecting cable. So we normally would use like a high temperature flexible silicon cable for that sort of stuff, and we actually put the fiberglass sheathing over it as well, so give you that extra layer of protection. So there's a couple of exceptions where an assessment is made of the effect of the fault in the electrical equipment, and smaller conductors will meet the protection requirements. Conductors with a cross-sectional area of not less than 20% of the rating of the circuit protective device may be used. Wiring between a terminating device and a pendant socket outlet is considered to be installation wiring. See clause 3974 and figure 4.8. So 4.4 on page 223, socket outlets. So socket outlets shall be suitable for the intended application and location of installation and shall comply with the requirements of the following standards or standards equivalent thereto. I'm not going to list them off. Socket outlets, alternative pin configuration. So socket outlets with alternative pin configuration, e.g. UK, French, German and USA type, shall only be used under the following conditions. The socket outlet shall be of a single set of apertures where any earthing contact and comply with an earthing contact and comply with the national standard socket as shown in IEC/TR 60083. Single set of pin apertures of socket outlets that accept multiple pin configurations shall not be used. So exception for that is a shaver socket outlet complying with NZS 3194. So you'll see them a lot in hotels, etc., airports, where I don't know too many blokes that would carry a shaver with them these days. That's 240 volt rated, but basically you can plug in in those airports or wherever you can plug in a shaver to shave your beard, etc. The installation of the socket outlet shall comply with clause 444. The socket outlet shall be rated at the voltage of the electrical installation unless supplied at a lower voltage, in which case it may be rated at that lower voltage. So perhaps you have a step-down transformer somewhere in the installation to suit countries that use a lower voltage. Socket outlets with alternative pin configurations normally supplying a voltage less than that of the electrical installation shall be supplied at that lower voltage. Again, step-down transformer potentially. And we also need to make sure the socket outlets have been tested and equivalent requirements of the standard listed in clause 44111, items A, B, C, and D above. So, I've never installed another country's socket outlet. I've installed another country's ceiling fans and things like that years ago. Actually, as an apprentice, we supplied a large step-down transformer because they brought some ceiling fans back with them from the States. So you can do it, but you know, it's obviously a different frequency, Australia and the States. So just be mindful of that. A low voltage fixed socket outlet. This is an amendment. A low voltage switch socket outlet or its faceplate should not incorporate a connecting device for telecommunications, data, television, radio, or other similar wiring systems. Just a note there, USB charging socket outlets are on the faceplate are acceptable. So you might go into an older home, they might have a double power point with an extra position in it, and instead of having a switch in there, they might have a data mech or a like a free-to-air socket potentially, or a Foxtel socket. It's not permitted, so it never really has been, to be honest. Different systems where an ELV electrical installation and an electrical installation of greater than ELV are in the same premise. All socket outlets supplied at ELV shall have their voltage conspicuously marked and be of a form that will prevent insertion of an ELV plug into a socket outlet connected to a circuit of greater than extra low voltage. So different plugs, different sockets for different voltages, guys, if we're using different installation wiring. Socket outlets for electrical vehicle charging. Information for the installation and location of socket outlets for EV charging station is provided in Appendix P. Location. So each socket outlet shall be installed so that any plug intended to be used with the socket outlet can be conveniently inserted and withdrawn and not cause damage to any flexible cord or cable connecting to the plug. So you don't want to be forcing power points between fixed furniture, things like that, so people have to bend the conductors to plug it in there. And again, here it says socket outlet shall not be installed where the withdrawal of a plug from the socket outlet is restricted by a permanent fixture or fitting within the installation. Protection of socket outlets. So, socket outlets shall be installed so that they will not be subjected to undue mechanical stress or damage in normal service. In addition, the following also applies. So, where installed in a floor or other horizontal surface, socket outlets shall be designed or arranged to prevent the accumulation of dust or water therein. So, some examples are those benchtop power points. Some of them are horizontal. So, it just always freaks me out when you see them, especially in kitchens near a sink, that all it takes is a kid or somebody to spill that water. The water's going to go straight into those open socket outlets. So it needs to be designed to prevent the accumulation of dust or water. We need to also think if it's installed within 75 mil of a floor, socket outlet shall be installed so that any plug used with the socket outlet is withdrawn in the horizontal plane. Socket outlets that shall be installed, a plug is not likely to become loose or to malfunction because of gravity, vibration, or the weight of the flexible cord or cable. Where installed in a location that is not readily accessible for the connection of a fixed or stationary appliance or a luminaire, the socket outlet shall be securely fixed to a structure or support to ensure that no mechanical strain is placed on the installation wiring connections when inserting or removing a plug from the socket outlet. So we have a couple of exceptions to that. The socket outlet need not to be fixed in position where the installation meets the following conditions. So cable connections are not subject to undue mechanical stress on any connection in accordance with clause 3726. So this is where the cable ties on our downlight sockets, fan sockets are used. The wiring system where likely to be disturbed is supported in accordance with clause 3933. The wiring system where installed in a suspended ceiling is supported in accordance with 3932. The conductors are flexible or stranded type. So if you've got flexible or stranded conductors, you don't necessarily need to comply with D, but it's just good practice. So if you've got an older home with solid core, make sure that you're always screwing off those 413 sockets. Insulated unsheathed cables, including exposed cores where sheathing is removed, are enclosed in accordance with clause 310.1.1. We obviously can't have them in any sort of hazardous areas. We also need to be looking at taking extra care for installing those socket outlets in areas that are supposed to be fire resistant or fire rated, or even acoustic rated as well. Earthing contacts. Now this one's important. Every socket outlet shall be provided with an earthing contact. So whether that is a power point or a point in the roof or a fan or a downlight, you need to have an earthing contact there, and there has to be something connected to that earthing contact. So, switching device. Each socket outlet shall be individually controlled by a separate switch that complies with either AS NZS 3133 or 60669.1 or 60947.3, which operates in all active conductors. Switches controlling socket outlets shall comply with clause 4442 and 4443. A single switch may be used for the control of two socket outlets located immediately adjacent to each other. A socket outlet that is rated at not more than 10 amps installed for the connection of a fixed or stationary appliance or a luminaire, and that is not readily accessible for the purpose, need not be controlled by a switch. So downlights, like you've got one switch controlling multiple there. A socket outlet that is switched by insertion and withdrawal of the plug is deemed to meet the requirements of this clause. So the rating. So each switch that we've installed should have or shall have a current rating at its operating voltage not less than the current rating of the socket outlet it controls. So if you've got a 10 amp socket, the switch will be rated at 10 amps at a minimum. 15 amps socket, the switch should be rated at 15 amp minimum. Where a single switch is used to control two socket outlets, as permitted by exception 1 to clause 4441, the current rating of the switch shall not be less than the total current rating of the socket outlet. So let's say you got two 10s, that'll be 20 amps, or the current rating of the overcurrent protected device on the circuit, whichever is the lesser value. So let's say you've got two 10 amp sockets on a dedicated circuit. Let's say for example for some heaters, you've wired it in 2.5, it's on a 16 amp RCBO. Your switch needs to be rated at 16 amps or greater, because that is the lesser value. So I should never really be switching anything less than 16 amps or more than 16 amps. Sorry. Location and marking. So each switch or means of operating the switch for a socket outlet shall be as close as practicable to the socket outlet and marked to indicate the socket outlets or the connected electrical equipment that it controls. Marking is not required where the socket outlet control is obvious because of the location of the switch. Obvious is a pretty funny thing. Like there's some numpties out there, so yeah, what's obvious and what's not these days, it's hard to grasp, I guess. It needs to still be installed in a convenient and readily accessible location if it can't be directly adjacent, and it needs to be as close as practicable to the socket outlet. The location of the switch shall be clearly and permanently marked at the socket outlet, and both the switch and the socket outlet shall be provided with legible, indelible, and uniform labels indicating their relationship. So where it says uniform, please don't mark one end with a label maker and the other end with a permanent texter. Just do both with a label maker. It's really not that hard. It's an exception when we need to mark it is if the socket outlet is located more than 2.5 meters above the ground, floor or platform, and provided for the connection of a specific lamp, luminaire or appliance, or it's not accessible for general use. So arm's reach, I would deem that. If anything's out of arm's reach as well, I would deem that as not being accessible for general use. So pendant type socket outlets, so they're the ones that hang from the ceiling. Switch incorporated in a independent type socket outlet attached to a flexible cord shall interrupt all live. So that's active and neutral conductors. So 2-pole switching. If there's an exception there, pendant type multi-phase outlet with switching only in the active conductors may be used where the outlet is not dependent on the supply cable for support. So if you've got a separate catenary or a jack chain holding that up, you can get away with not switching to neutral. Additional mechanical protection is provided where necessary, and the supply cable or cord is selected to take into account any likelihood of vibration or movement expected during operation. Right, so pretty easy that one. Where socket outlets of the same type form part of an electrical installation, the order of connection of the socket outlet shall be the same. So all socket outlets that accommodate 3-pin flat plugs shall be connected so that when viewed from the front of the socket outlet, the order of connection commencing from the slot on the radial line shall be earth, active, neutral, in a clockwise direction. So that's going to form part of your polarity checking. If you're wiring up plugs, if you're wiring up sockets, the front. If you're looking at the front of the socket, the order of connection commencing from the slot on the radial line, so the vertical line shall be earth. You go clockwise from your earth, that is going to be then become your active, and then your neutral in a clockwise direction. And it doesn't matter which way that outlet is, it's always going to be the same polarity. Lamp holders, including incorporating a luminaire, so lighting equipment and accessories. So lamp holders, including lamp holders incorporated into a luminaire, shall be located to be adequately protected against damage that might reasonably be expected. So, you're changing a light globe, globes can shatter, and you just end up with a stem, especially the Edison screw ones, just stuck in the holder. You want to make sure, in order to protect against inadvertent contact with live parts, low voltage lamp holders shall be located to minimise the risk of direct contact with live parts of a lamp holder when the lamp is removed, and mechanical damage is to the lamp or lamp holder. These requirements may be satisfied by either installing the lamp holder itself not less than 1.8 metres above the ground floor or platform, or provision of a suitable guard for the lamp and its lamp holder. So if you've just got a bare globe hanging in a lamp holder, it needs to be more than 1.8 metres above the ground, or it needs to have a suitable guard for the lamp and its lamp holder. So it's a pretty tricky one, because you get a lot of clients that want pendants installed, probably either side of their bed. They want them down nice and low so they can read their books, etc. The fittings they choose might not necessarily have a suitable guard for the lamp or its lamp holder. So there's potential for fingers to find their way up in there, especially if they've got young kids, if there's no lamp in there. So you need to have that conversation with them. At the end of the day, it's your license on the line. Either they can get a ELV or SELV fitting, because a lot of the stuff we install now is all integrated LEDs, where the 240 volt connections are at the ceiling height or within the ceiling, so they're nice and safe. So just be mindful of that when you are choosing, or your clients are choosing, and you're installing those lights. Maybe have that chat with them about that sort of height requirement to make it safe for them and their kids. Edison screw lamp holders. So that's the one where you've got obviously the E27 globes, are probably the most common ones. You can do have the small Edison screws for like rain shoods and things like that too. Basically, we want to make sure that we connect the outer contact is actually a neutral conductor, and the contact at the very bottom of where the lamp's going to screw in and touch that's the active. Just because if you have it the other way around, what can happen is you've got more of a chance of getting an electric shock as you're screwing the globe, and your fingers might actually be touching on part of that thread, and you don't want that to be live. So just to have a bit of a think about that, especially if you're rewiring fittings. Just make sure that that's the case when you're doing it. And it's actually a really good thing to check. We've had multiple fittings that they're approved to be installed in Australia, but they have that around the wrong way. So just have a look to see if it is actually wired up that way from factory, because a lot of the time it's not. I remember as an apprentice, it was like 2 days before Christmas, and we were installing some client supplied 240 volt downlights. Back in the day, what were they? The G10 lamp holders, and it came from the factory, and we were installing them in some eaves, and myself and my tradesman, it was pretty hot. It was our last day at work, and yeah, one wasn't working, so like, straight away I got the blame for, oh, you've must have wired that socket up wrong, or go change the globe, do whatever. And I was in the middle of doing some cleaning up, and my tradie was like, oh, I'll just go and quickly do it now. He's reached up above his head to grab the 240 volt downlight out of the roof, and it's given him a whack. So out of the factory, they've actually transposed active and earth somehow on the 3-pin plug. So just, yeah, be careful out there, especially if you're altering existing fittings as well. It can be quite painful to cop a boot. So just double check that you've got that earthing all connected up right, you've got your neutral in the right spot, and your active is in the, I guess, the furthermost part of that socket. Festoon lighting should be located, so that's the lighting you see in a lot of pubs, cafes, things like that. Basically, you need to make sure that no lamps on that festoon are within 150 millimeters of flammable materials or structural metalwork, or any of it's within arm's reach of the ground or any other place on which a person is likely to stand. So you could argue in a pub that somebody is likely to stand on a table. I've seen plenty of people stand on tables, especially after a few too many naughty waters, and maybe they're watching their favourite footy team or their favourite soccer team kicking a couple of goals. So just, or having a big win. So festoon lighting may be within arm's reach, or it's installed immediately below a ceiling, because you don't really have any other choice. But yeah, again, maybe have a think about that environment you're installing it in. Is it likely to be actually hit by somebody's arm or something like that? Lamps, luminaires, and their associated ancillary gear shall be installed so as not to cause undue temperature rise, ignition, or deterioration of the materials on which they are mounted or that they illuminate. So we want to make sure that our lamps aren't providing excess heat. Lamps near flammable materials. Where lamps are located near flammable materials, lamps shall be suitably shielded by a shade, reflected guard, or enclosure to prevent contact with material. And lamps such as spotlights that generate heat in the illuminated surface shall be separated by such a distance that the material will not attain excessive temperature. Where information is not otherwise provided with products, the minimum separation distance given in table 4.2 shall be used. Flammable shades shall not be installed where they are liable to come in contact with any lamp. So the old shop lighters, so they're like a linear, some were 150 watt, like a linear halogen, some were 150 watt, some were 500 watt. They actually pumped out a heap of heat, and especially depending on the surface that they're installed on, like gyprock surfaces especially. We did a fair bit of shop maintenance, and the gyprock was charring around the edge of the lights, and you would take them out to replace them with an LED equivalent, and the gyprock would just crumble. So we need to be really careful about what we're installing and into what material. Obviously, gyprock is got paper either side of it to hold it all together as well, so that's quite a flammable thing. So we just need to be very mindful about that sort of thing. Also, there was a stage where the oyster lights, obviously now we've moved all to LED. Oyster lights, basically all integrated LEDs, but there was a period of time where oyster lights had linear halogens within them, and they relied on like a very thin silver reflector to dissipate that heat and sort of focus, I guess, all that heat energy back down to the area where you want to install it. And I've come across, see if I can find some photos from back when I was an apprentice. I reckon I'll have them on my Google Drive or something like that, where there was just a big char mark in the ceiling, and it had charred so much that all the gyprock had fallen down, and there was like a pathway up into the roof space. So just be really thoughtful out there, guys, about the sorts of lights and the long-term effect that excessive temperature rise is going to have on the building materials you're installing it on. If you're not sure or you can't identify anything, just have a look at table 4.2, and obviously just approach it with that common sense method as well. Like, hey, this is getting hot in like a minute or so. If this is left on all night or all day or 24/7, how hot is this surface temperature going to get? And will it become detrimental? If the answer is yes or maybe have a bit of a look for a different product or install that fitting a bit further away. So we've got now obviously our new downlights, recessed luminaires are generally ICF rated, which is brilliant because we don't have to worry so much about how the proximity of that fitting is to combustible building materials such as timber, like for downlights, especially for like timber supports in the roof, thermal insulation, or also actually flammable building materials where we're mounting it. So ICF has really made life easy when it comes to that sort of, that ICF rating has really made life easy when it comes to installation of luminaires, and especially now that we're getting like lights. There's some manufacturers out there that have got lights that are less than 10mm thick, so you don't even have to put a lot of thought into where your timbers etc are at all in the roof, which is a big change from when I was an apprentice, when we had to do our mark out for our downlights. We would jump up in the roof, we would make sure we've got, I think it was 300mm clearance between or 100, it might have been 100mm. It's going back, I'd have to check out my latest, some earlier releases for AS3000. So you'd imagine you've then got, not only are you trying to miss building material, you then got to remove flammable or bulk insulation from the roof space or installing ceiling cans. So it's just an example of how far the industry's come in such a short. Like, I've been in the industry now for 16, nearly 17 years, and that was so tricky. Like, LED fitted downlights weren't even around when I started my apprenticeship. So now we've got LED downlights that are less than 10mm thick, so we can, if we've got a 10mm ceiling, we can cut them wherever, obviously making sure there's not any water pipes etc, and we can install them wherever because they're ICF rated, they're less than 10mm, and they can abut flammable material. I see, so we've installed warning signs. So where recessed luminaires are installed in accessible roof space, a permanent and legible warning sign shall be installed in the roof space adjacent to the access point in a position that is visible to a person entering the space. The sign shall contain the words shown in figure 410 with a minimum size lettering of 10mm. I guess that's a good thing. There's an exception around this where all recessed luminaires installed in accessible roof space are of either IC or IC4 classification. The warning sign's not required. Is it a good idea to have it regardless? Yes, because obviously you can replace those fittings with something that's not IC or ICF4 rated. But also, like, where do you draw the line? Like, there's people out there that can't read. There's also people that don't read English. So what are we supposed to have, like a warning sign with multiple languages on it? Like, I understand the purpose of the sign. Is it, it just seems a little bit of overkill to have. And then, just saying, oh, we've got all IC or IC4 rated fittings, we don't need the sign. Well, it's again, it's that common sense thing, but we've got to meet these minimums just to protect ourselves. So, just making sure there's that. Recessed luminaires need to be designed and certified, and they need to be marked accordingly, so you don't install things that don't have the correct certifications printed on them. We also need to just double check the manufacturer's instructions around restrictions for installation for certain applications. Anything that's unmarked needs to be treated as do not cover. For these typical fittings, the installation method shall be to provide barriers. So we used to install like little cans, like aluminium perforated cans, so that you can't get any build up of heat, which just takes time. Time is money, so just be mindful of the fittings you're choosing. If the client's providing things that you're not really too happy with, just let them know that, hey, look, I'm not really real stoked on this. Let's use something else. Perhaps here's something that I recommend, or perhaps go to a lighting supplier to choose it. I'm not going to run through all the IC ratings of the fittings that we've got because it's just all listed in tables. I would recommend certainly having a look at those tables yourselves. That's table 4.3 starting on page 238 in NZS 3000. Have a read of that. You'll learn a fair bit out of them. So suspended ceilings, so like a lot of commercial buildings are suspended ceilings. Some domestic have suspended ceilings as well. We need to make sure that the ceiling panel or the lighting that we install in ceiling panels don't present any mechanical loading that exceeds the capacity of the ceiling panel. Obviously, we don't want to overload that ceiling system. We also need to make sure we don't install lighting that operates at temperatures that would cause deformation, discoloration, or other forms of deterioration of the ceiling panel. So some panels might require extra supports as per their own installation manuals. So just refer to any of the manufacturer's information for limitations on particular ceiling systems, or have a chat to the ceiling contractors that are there. They should be able to tell you. Whether or not they will or not is another story. Smoke alarms. So obviously national building codes and state legislation differs state to state around smoke alarms, including the location number required and the interconnection for alarm purposes. Where mains powered smoke alarms are fitted, such alarms may be directly connected to the lighting final subcircuit to an individual final subcircuit. Or to an individual final subcircuit, so it could be either power or lighting. Use of the lighting final subcircuit provides indication that the mains power supply is available, as a loss of supply to smoke alarms in an electrical installation would be indicated by the non-operation of lighting. Smoke alarms are not considered to be safety services for the purpose of this standard, so that you don't have to wire them in special cable. So cooking appliances, so switching device. A circuit for a fixed or stationary cooking appliance having an open cooking surface incorporating electric heating, for example a cooktop, deep fat fryer, barbecue griddle or similar, shall be provided with a switch operating in all active conductors mounted near the appliance in a visible and readily accessible position. This requirement does not need to apply to enclosed cooking appliances such as built-in ovens and microwave ovens. It might be a good idea to still have a isolation switch for an oven. You might have toddlers running around at home, and you don't want them accidentally mashing buttons and turning ovens and things like that on. So it could be a good idea to have it, but minimum standard is you don't need it. You can't mount the switch on the cooking appliance, and it needs to be within 2 meters of the cooking appliance. Also, you can't have it in a position where you have to reach across the open cooking surface to operate it. The idea is that if something's on fire or in that cooking surface, on a pot or something like that, you can turn it off. So there's an exception where an electric cooking surface is installed in a public park or other open area to prevent damage by vandalism. The switch may be installed under a lockable cover that is located so that it is able to be operated as required for servicing and maintenance purpose of the cooking service. Because there's people out there that just like to ruin things just for the fun of it. So obviously if we had an isolator in public places, it's very easy for that to be damaged, expose live parts, and then people can get hurt pretty quickly. Socket outlets and switches shall not be installed in the prohibited location shown in figure 417 on any wall, cupboard or other surface within 150 mm of the edge of an open gas or electric cooking surface, in the area extending from the top of the cooking surface to a range hood, cupboard or ceiling located directly above the cooking surface, or 2.5 meters above the floor that is directly below the cooking surface, whichever is lower. So there's a figure there on page 245. Have a bit of a look at that. It's a bit of an amendment, and it's just a common sense thing. Like, you don't want anything too close to that because it's going to be affected by the heat. Appliances producing hot water or steam shall be protected against overheating by design or installation in all service conditions. Protection shall be provided by means of an appropriate non-self-resetting device functioning independently of the thermostat. This requirement does not need to apply to appliances that comply as a whole with an appropriate standard. Where the appliance has no free outlet, it shall also be provided with a device that limits the water pressure. So, hot water services, things like that. Not that we install them, but they've given a device, like a pressure temperature relief valve. So as the water heats up, it actually expands, and it'll allow that relief will open and allowing that pressure to stay at a suitable pressure to be withheld within that equipment, because you obviously don't want a build up of pressure, heat, and just it goes up and up and up and up and up. It become quite dangerous. So water heaters, so access to easing equipment of pressure relief and terminals of protective devices. Every unvented water heater shall be installed so that the following are readily available for operation, inspection and adjustment. Easing equipment of pressure relief devices, terminals of the protective devices. That's why you'll see your hot water services, etc. will have a very readily accessible cover. Every hot water heater that is fixed wide shall be provided with an independent isolating switch lockable in accordance with clause 2322. The isolating switch shall be additional to any automatic switch incorporated in the heater structure and installed adjacent to but not on the water heater. Where a water heater is supplied by two or more final subcircuits, all of the final subcircuits for that water heater shall be capable of being isolated by a single isolation switch. So you've got a dual element hot water service. So you've got a top element, which will basically be a boost element for that hot water service, and then you have a lower element which will generally be on a controlled load, so it'll be controlled by your power authority on or off. You just need to make sure that you use a multi-pole isolation switch that's labelled accordingly, that you can turn all active conductors off, all live conductors off. With that, you don't necessarily have to switch the neutral. Again, it's a good idea to switch that. And that's a new rule. There's still so many people out there that aren't doing it. The reason of that rule is we've had, unfortunately, a few plumbers pass away due to being electrocuted. They test for dead. It's dead. They start removing that hot water heater, or maybe they're servicing the element or the thermostat, and they haven't isolated the correct circuit, and time of use tariff is then enabled by the retailer. The equipment they're working on then becomes live, and that's how they've copped the boot and unfortunately passed away. So I think it's a really good rule. It's extra work for us, which is good. You make more money, you get more margin, and it's a safety thing for both users and service personnel. Room heaters. So where a permanently connected room heater or a number of permanently connected room heaters are installed in one room, an individual isolating switch and an individual functional switch shall be provided for each room heater or for each group of room heaters. So isolation switch is how you can turn it off and isolate everything from the electrical supply. Functional switch is different to an isolating switch. A functional switch is how the user will turn the equipment on and off, or the equipment is then controlled, whether that's through a thermostat. Electric heating cables for floors, ceilings and trace heating applications. They need to be of a type specifically designed for the purpose. The heating equipment shall be installed in accordance with the manufacturer's instructions. The heating cables shall be installed so that they are not in contact with flammable materials, and where designed to be embedded, are completely and adequately embedded in the substance they are intended to heat, and do not suffer any detrimental effects because of flexing or movement from the substance in which they are embedded. Alternatively, where designed as trace heating cables shall provide adequate heat transfer to the surface of material to which they are fixed. Isolating switches. So cables or groups of cables that comprise with heating systems shall be provided with an isolating switch or switches in accordance with clause 2322. Isolating switches may be incorporated in temperature control devices provided they have a definite off position. So some thermostats have a temperature range, but then past a certain range they'll click to an off position. Isolating switches shall be installed immediately adjacent to an entrance to or within the room or area in which the heating system is located, or installed on the switchboard at which the heating system final subcircuit originates. So functional switches again. Cable or groups of cables that comprise of the heating system shall be provided with a functional switch or switches in accordance with 237. They need to be installed in a readily accessible position, adjacent to an entrance or to or within the room or area in which the heating system is located. A functional switch may be an isolating switch in accordance with clause 410.3a. If it's intended for trace heating applications, the functional switch need not be located as specified in this clause. Additional protection. All heating cables shall be provided with additional protection by an RCD with a fixed rated residual current not exceeding 30 milliamps, and in the case of heating units fitted with a conductive covering, this covering needs to be earthed. In the case of underfloor heating units without a conductive covering, an earthed metallic grid with spacing not exceeding 30 millimeters shall be provided above the underfloor heating cable, and heating unit shall be provided with adequate mechanical protection to prevent damage. Now that's pretty interesting. So 410.5, additional protection in the case of underfloor heating units without a conductive covering, an earthed metallic grid with a spacing not exceeding 30 mm shall be provided above the underfloor heating cable, and that's regardless of if it has RCD protection or not. So that's, yeah, I bet that doesn't happen. I see a lot of underfloor heating guys out there. They put their before and after pictures of their nice, neat underfloor heating, electric underfloor heating in. I've not ever seen one that has that earthed metallic grid above it. So, I mean, it makes sense to have it because you might be jackhammering up a slab that's bone dry. So no earth conductivity on it, and you hit an active, yeah, the RCD is not going to operate unless it goes through your body, which we obviously want to prevent. So yeah, that's the first time I've actually read that exact. Well, I might have read it as an apprentice, but I probably didn't pay much attention to it. But yeah, that's interesting. So heating cables are installed. We need to put signage up. Electric duct heaters. Now, so this is electric heat. So in SA, we don't have a lot of this because our climate doesn't get that low. Victoria, Canberra, Sydney, Tasmania, and maybe the southern side of Western Australia probably use this a little bit more than us. But basically, that's where your reverse cycle ducted's not keeping up because your outdoor ambient is so low. You have a set of resistive heaters in your ductwork, which will turn on and off. There's some few standards around that, so it doesn't actually fall within AS 3000. It falls under AS NZS 16681. The safety requirements for that are in 3102, and there's also regulatory requirements around how we can switch them because they are such a high load. Electricity converters. For the purpose of this clause, an electricity converter includes both static and dynamic equipment designed to stabilise the supply voltage or to change the voltage or frequency of an electricity supply, or to maintain a continuous electrical supply for a limited period of time when the primary source of electricity supply is interrupted. So that would be a UPS, which basically is uninterruptible power system. So semiconductor power converters and inverters, voltage stabilizers, motor generator sets, or rotary converters. So transformers and engine-driven generating sets that comply with AS NZS 3010 shall not be considered as electricity converters. Requirements for alternative, standby, and standalone systems are set out in clause 7.3. So we'll get to that in another couple of weeks. Selection and installation of UPS systems. 60 is part of AS NZS 62040. Semiconductor power converters AS 60146. For batteries AS 3011, and for rotating electrical machines AS 60034. Control. When electrical installation or part thereof is supplied through an electricity converter, the converted supply shall be controlled by an isolating switch or switches at the output of the converter or at the switchboard to which the output is connected. So that's why you'll have a solar AC feed main switch. Well, it'll be labelled as a main switch, but it'll just be a circuit protection device, like a circuit breaker. Electricity converters may be arranged to supply energy upstream of the point of connection to the installation, subject to any additional conditions required by the electricity distributor. Provision shall be made to ensure that all necessary connections for protection in the installation remain intact when supply is available from the output of the electricity converter. We don't do a lot of solar. Like I've got my solar, so my not my standalone, but just my Grid Connect design and install ticket, as well as my battery ticket. I don't use it. We give our solar and battery work to somebody else, just because it's such a fast-moving industry. If you don't do it all day, every day, you can be left behind pretty quick. Firm believer of aces in their places. So yeah, we just try and stay away from that. Isolation. Each electricity converter shall be provided with an independent isolating switch in accordance with 2322. So it needs to have a means of securing a device in the isolated position that requires a deliberate action to engage or disengage it. So you can't just accidentally bump it and it turn on. Overcurrent protection, electricity converter protection, basically needs to be provided with overcurrent protection. It's no different to being supplied from the grid. We still need to have overcurrent protection. There's an exception that if the overcurrent protection devices shall not be provided if the unexpected interruption of the supply could cause a greater danger than overcurrent. The overcurrent protection devices need to be located as close as practicable to the output terminals of the electricity converter, so that the unprotected interconnecting conductors are as short as practicable and in no case exceed 15 metres in length. Unprotected interconnecting conductors shall be completely enclosed by metal or other material that is not flammable. So it's a pretty interesting one. Again, it probably doesn't really, for domestic sparkies that aren't doing battery, solar, etc., it probably doesn't really affect us too much. Industrial guys that have got standby generators and things like that, commercial, hospitals, things like that, it definitely does apply to them. So circuit protection. Again, every submain or final subcircuit outgoing from an electricity converter shall be individually protected in accordance with Clause 2.5, and shall also include additional protection where required by Clause 2.6. RCDs. So, the possible waveform of a fault current to earth can affect operation of RCDs and should be taken into account for the selection of the type of RCD. So, where an electricity converter includes an inverter, the RCD shall be of a type suitable for the waveform of the particular inverter and in accordance with the inverter manufacturer's recommendations. You need to make sure that obviously it trips when it's intended, but you also want to make sure it doesn't trip when it's not intended to, so it's a good one to make sure you got that. And that's why we've had that big change in the approvals of what RCBAs were allowed to use, because of the uptake of solar and DC batteries in being installed within homes and premises. Electricity, the neutral continuity. Electricity converters, particularly static converters such as UPS, shall be arranged to ensure that the continuity of the neutral conductor to the load is not interrupted during bypass or maintenance switching. Electrical equipment connected to the output. All electrical equipment connected to the output side of an electricity converter shall be suitable for the voltage, current and frequency of the output of the unit. So just make sure that you've got the right frequency, the right voltage, and the current's going to be suitable for that equipment you're plugging in. Motors. So we want to protect against injury from mechanical movement. So we don't want people coming into contact with a rotating mechanical equipment attached to the motors. You want to make sure that we have a switching device capable of performing all of the following functions. So starting and stopping the motor, emergency stopping, and isolating the motor for mechanical maintenance in accordance with Clause 236. So wherever a number of motors are required to function as a group or operate in a coordinated manner, for example, a split system air conditioning unit, a single switching device may be used to control more than one motor. Refrigeration is a pretty good one for this one. We don't want to isolate just the indoor fans on a refrigeration system, because we can actually damage the compressor outside by liquid slugging, because we're not getting that evaporative effect happening within the coil with the refrigerant. So if we're going to maintain that equipment, we need to isolate all of the equipment. So it's a good example. A split system air conditioner, a lot of people think it's like a wall split. Split system is basically anything where you've got an outdoor unit and an indoor unit. That is a split system. So just think of it like that and you should be good. A switch suitable for disconnection of supply in accordance with item C need not be provided for motors that are connected by a plug-in socket outlet, so like a rainwater tank pump. They're incorporated in an appliance having no exposed moving parts. Again, rainwater pump, pool pump, hot water heat pump, because sometimes they're just plugged in with a plug-in socket, or rated at not greater than 150 VA. So exhaust fan above your shower, probably less than 150 VA. Range hood fan motor. For domestic, probably less than 150 VA, so we don't need that switching device. Rating of switches. So the isolating switch shall have a rating of not less than the full load current of the motor when installed directly in the motor supply circuit, or the control circuit current when installed in the motor starter circuit. Any switch operating directly in the motor supply circuit should be capable of safely interrupting the locked rotor or stall current of the motor. So in the absence of any specific information supplied by the manufacturer, the locked rotor or stall current shall be taken as 8 times the full load current for AC motors, or 4 times the full load current for DC motors. So we've got quite a... We need to make sure that under fault conditions, like let's say we've got a seized compressor, we're going to draw a lot of current. We need to make sure our isolating switch is actually capable of breaking that current and that arc that's formed while switching that fault current. Because if you don't, you might end up just welding your contactor or your isolating switch shut, and you will never be able to isolate that equipment, and it will more than likely trip your circuit protection, or maybe even your service fuses, depending on the size of the motor. Starting and stopping devices shall be located to be easily operated by the person in charge of the motor. So if you're, I guess for maybe a timber workshop, you've got a dust extraction system, you might have multiple stop-start stations around the area, but you basically want it so that if one person requires the extraction system to run, they hit the start button on their bit of equipment, like they might be working on a bandsaw. They hit the start button, starts up the extraction system. Somebody else comes along and starts working on another bit of equipment on the other side of the workshop. They might be on a drop saw, and they hit the start button, and old mate finishes on his bandsaw. He hits the stop button, but the dust extraction system still runs because we've still got somebody over on a drop saw performing cuts. So there's obviously rules around that. So just have a think about how that installation is intended to work, how many people are going to be operating it. If there's any emergency stops, though, it doesn't matter which emergency stop button is hit, it will still shut off that whole system because, again, it's an emergency stop. Protection against restarting or reversal. So where unexpected restarting of a motor might cause danger, either each electric motor shall be provided with means to prevent automatic restarting after stopping. So a good example for that would be thermal overloads. You'll see they're generally on a lot of motors now. They'll have a warning sticker saying that this motor has been fitted with internal thermal overload protection. It may stop or start by its without warning. So we just need to make sure that we can actually basically we really want to make sure that people are aware that that's going to be a problem, and that there's a suitable isolating switch that is basically can isolate that equipment 100%, and it's in a local, very close by location, or it's suitably labelled. Protection against overload. Each electric motor having a rating exceeding 370 watts shall be provided with control equipment incorporating means of protection against overload of the motor. Doesn't have to if the electrical equipment complies with an appropriate standard. You can either have internal overload or external overload for motors. A lot of the larger equipment will have external overloads, generally at the contactor, and you can adjust that. Internal overload is generally by forms of like a Clixon and you can't manually reset them. So they basically, once the equipment's cooled down, it's got the potential to restart itself if you've still got power energized. Just a bit of advice, especially for air conditioning stuff or air compressors, things like that. If you get to a site and your thermal overload's activated internally and you need to cool that compressor down, whether that's by means of water over the top of it or your bag of ice sitting on top of it, whatever it may be, it's just because your thermal overload's opened or closed back together and it allows that equipment to run. Just continue to cool that for a little bit longer, because your startup current might then overload that motor straight away, overheat it straight away, and it'll just, you're back to square one, cooling that down again. So once your overload circuit closes, again, just continue to cool it for another 5-10 minutes and you should be good to go. Protection against overload we've spoken about, but we also need to have a quick look about motor reversal. Reverse current braking is used quite a bit in industry, so we just need to make sure that we don't inadvertently start spinning our motors the wrong way. Over temperature, again, we need to make sure that over temperature protective devices, especially if equipment's designed to be run unattended. For shaded pole motors, it's in greater than 480 VA, or for other unattended motors, 240 VA. So we just don't want to accidentally overheat things and cause fires when motors are left running unprotected. Protection prohibited. So over temperature protection shall not be provided in either of the following circumstances. So fire protection services, so smoke spill fans, we really don't want them to have any form of thermal overload. So they're designed to run till destruction. Again, they're expelling extremely hot smoke, fire. They need to continue to run to help preserve life, but also stock and firefighters fighting that fire within that building. So if we have a thermal overload in a smoke spill fan, it wouldn't take very long for that to go out in thermal overload, and it will never reset. So those motors are designed specifically to run to destruction. We also need to make sure that if we've got protection, protection prohibited, if let's say the protection opens and it causes more danger than that of the motor circuit stopping, we just need to ensure that motor continues to spin. But we might need to have a look at maybe having some over temperature alarms or over temperature lights for the operators to actually understand that, hey, look, we've got some temperature issues or some current issues within the motor. They can then safely shut that equipment down. It's just a common sense approach. Transformers need to be installed in accordance with 4.14.2. The following transformers need not comply with the clause: an instrument transformer, an ELV transformer, a luminous discharge tube transformer, or a transformer incorporated in a motor starter or similar electrical equipment. So that sort of stuff doesn't really require to be comply with those clauses. Secondary circuit, so the wiring electrical equipment connected to the secondary winding of a transformer shall comply with the requirements of the standard for extra low or high voltage as appropriate to the normal secondary voltage. So, control and protection. The conductors connected to the secondary windings of a transformer shall be considered as sub-main or final sub-circuit conductors as appropriate. So if you've got a transformer supplying then a little subboard, it then becomes a sub-main and you need to protect it appropriately. If it's supplying one final sub-circuit, you need to protect that appropriately as well. But you also need to install the cabling linking that equipment as per whether it's a final sub-circuit or a sub-main. Low voltage transformer supply, so you've got an isolating transformer, which basically has no reference to earth. You'll see that a lot in pool lighting equipment. You've got auto transformers, step-up transformers, where a step-up transformer basically We might have 240 volt in, we might be stepping it up to 260 volt to run specific equipment. I'm not a guru with transformers or motors in any way, shape or form, but yeah, it's a bit of an interesting thing. Capacitors need to be installed in accordance with clause 4152 and 4153. Electrical equipment and wiring for connection to capacitors shall be suitable for the highest voltages, currents and temperatures that are likely to occur. Adequate means shall be provided to ensure the dissipation of heat from the electrical equipment. So, capacitors, a lot of people are like, oh, 440 volts, or that's what my capacitor creates. No, it's not. It's actually the back EMF that capacitor can hold, can withstand from your motor. Capacitors don't boost the voltage in any way. They allow current to flow. They're pretty interesting. I'll actually do a video on how a capacitor works. Actually, it's a good one. There's a lot of misconception around that, how a capacitor works. So, discharge and control of capacitors, so power factor correction and stuff, need to be provided with a discharge path. You need to be able to, the voltage between capacitor terminals shall not be more than 50 volts after the capacitor has been disconnected from the supply for the following period as applicable. If the capacitor is rated up in including 650 volt, 1 minute. If it's above 650 volts, 5 minutes. You also need to make sure that the capacitors are completely discharged before working on equipment. There's lots of different ways to do it. The safest way to do it is with a bleed resistor. Some capacitors can be connected in parallel with individual appliances. They've got a few requirements, such as the capacitor shall be connected so that the windings of the appliance form a permanent discharge path for the capacitor, and no switch or fuse shall be inserted between the capacitor and the appliance. The requirements of items A and B need not apply where the capacitor incorporates a permanently connected discharge device. So you'll see on a lot of start caps, there's a permanently connected resistor across the terminals, and that is your permanently connected discharge path. Capacitors not connected in parallel with individual appliances. So capacitors not connected in parallel with an individual appliance shall comply with the following requirements. The capacitor shall be controlled by a circuit breaker fitted with an overcurrent release. Provision shall be made for the discharge of the capacitor by the use of auxiliary contacts of the circuit breaker that automatically connect a discharge device to the capacitor immediately when it is disconnected from the supply, or a permanently connected discharge device in parallel with the capacitor. Exceptions here is if the capacitor is rated at no more than 100 kVAr, which is reactive power, or each capacitor in a bank of shunt-connected capacitors is rated at no more than 100 kVAr, again, reactive power. The capacitor may be controlled by quick make and break switch or contactor and protected by fuses, provided that the following requirements are met. Such switching shall incorporate a means of manual operation to provide for the individual isolation of each capacitor or for the capacitor bank as a whole. Provision shall be made for the discharge of the capacitor by the use of a permanently connected discharge device in parallel with the capacitor. No fuse or switch shall be connected between the auxiliary contacts of the circuit breaker and the discharge device referred to in item AI, or the permanently connected discharge device and a capacitor referred to in item AII. So, electrical equipment containing liquid dielectrics. So, wherever electrical equipment such as oil-filled transformers or capacitors contain flammable liquid in significant quantities, precaution shall be taken to prevent burning liquid and the product of combustion of the liquid, flame, smoke or toxic gases spreading to other parts of the premise. So, liquid dielectrics having a flash point not exceeding 250 degrees Celsius. Where electrical equipment is filled with a liquid dielectric having flash point not exceeding 250 degrees Celsius and has a total liquid capacity exceeding 50 litres in any unit or group of adjacent units, precautions shall be taken to prevent the spread of fire. Such precautions may include the provision of enclosures consisting of fire-resisting dikes, bunds, curbed areas, basins, trenches filled with coarse crushed stone, or where necessary, trapped drains. So this might be if you've got your own transformers on site. I've not actually ever dealt with any of these liquid dielectrics in transformers or anything like that. But you actually see if you're driving down the road, most transformers, or a lot of transformers, will have it looks like a 2-inch ball valve on the bottom of them. So you can remove the oil and replace if required. Batteries. So batteries will be pretty well disregarded in AS3000. It just mentions here to reference AS3011.1 and AS3011.2. Gas appliances and equipment. A gas appliance connected to the electricity supply shall be provided with a means of electrical isolation that is adjacent to the appliance location and is accessible with the appliance in the installed position. So for cooking appliances, the means of isolation shall not be mounted in the prohibited location specified in 473 and 417 for clearance from open cooking surfaces. Again, that's just a safety thing, because if there's a fire and you want to isolate it, you don't have to reach across the top of the open cooking surface and burn yourself. If the appliance has an open cooking surface incorporating both gas and electric cooking, it shall also comply with clause 4.7. In Australia only, one of the following means of isolation shall be provided for the gas appliance. So a plug to an accessible switch socket outlet, or a plug to a socket outlet that may be located in an inaccessible position but has a separate switch operating all live. So that's active and neutral conductors that is located in an accessible position, or an accessible isolating switch which is lockable operating in all live, active and neutral conductors. So a plug to an accessible switch socket outlet, that's easy enough. A plug to a socket outlet that may be located in an inaccessible position but has a separate switch operating in all live and active neutral conductors that is located in an accessible position. So if you have a gas cooktop, you need to ensure that there is a double pole isolating switch that operates the power point that it is plugged into if that power point is not readily accessible. So a readily accessible outlet, in my opinion, is in a cupboard adjacent, that you don't need a tool to remove shelving to then access that power point. If you can't supply an accessible socket outlet, you need to have a switch that you can turn the active and neutral off for that particular socket outlet. So a lot of electricians don't really understand that rule. It can trip you up, especially if you get some of these fancy homes with nice neat splashbacks, or you're first fixing a stone cottage or something like that, like part of a reno. If you forget to put it in, it'll be a bit tricky to sort it out if you don't have an accessible point to isolate it. And some plumbers will actually pull you up on that pretty quickly. They will refuse to connect it until you fix it. So gas cylinders containing heavier than air gases outdoors. We need to be pretty mindful of sources of ignition. Obviously, we don't want, if there's the event of a gas or the gas vents and creates a flammable atmosphere, we don't want any form of ignition source adjacent to that. So electrical equipment that is a source of ignition, such as socket outlets, switches, luminaires, switchboards, meter boxes and air conditioners, shall not be installed within the hazardous areas shown in figure 4.18 by dimensions A and B. Dimensions A and B are shown in figure 4.18 for both exchange and in situ filled gas cylinders. Approved combined gas and electrical meter enclosures are exempted from these requirements. So if you've got an approved meter board that is electric and gas, like one on top of the other, generally it'll be electrical on top, gas beneath, it's deemed to comply. Hot particles and surfaces, again, refer to clause 7.7 and also NZS 60079.14 for exclusion zones in hazardous areas. So the figure 4.18 is on page 262, and it basically gives us a picture of a gas cylinder with A, which is the radius from the top of the cylinder, so maybe 500 mil above the top of the cylinder. A is a dimension for the top of the cone, and then B is the dimension for at the bottom of the cylinder, will give us your bottom radius for the bottom of the cone. There's a difference between an exchange cylinder and an in-situ fill cylinder. So just make sure you can determine the differences between the two. Exchange cylinders will basically be where a truck comes up, fills your cylinder for your own home use. An in-situ fill cylinder is you've got like a large cylinder that you then fill other people's smaller cylinders. So like maybe at your local car wash or your hardware store where they fill your own cylinders. That's the difference between the two. So the in-situ fuel cylinders has a larger exclusion zone because it's presumed that you will have gas leakage most of the time while you're filling other people's cylinders, especially if you overfill them. Gas relief vent terminal, so natural gas, LPG gas or biogas. Electrical equipment that is a source of ignition, such as socket outlets, switches, luminaires, switchboards, meter boxes and air conditioners shall not be installed within the hazardous area shown in figure 4.19 for gas relief vent terminals. So it gives us here, this is page 263. It'll give you a vent terminal discharge point. It'll give you a discharge direction. It'll give you a diameter not exceeding 50 mil. It'll give you all different distances and radiuses that we need to sort of comply with to make sure that that area adjacent that discharge vent does not become a point of ignition. So that's more so for like your meter boards and things like that. We've got here also hazardous area for reticulated gas supply regulators. That's New Zealand only. In South Australia, we've got a few different regs for this. So APA do most of it but up in Mount Barker there's another gas authority up there. For the life of me, I can't remember what they are, but they've got slightly different rules than the APA rules because they're actually using bottled gas and reticulating bottled gas through all these new estates up in Mount Barker because there is no gas mains, so to speak. Air conditioning and heat pump systems. So air conditioning and heat pump. So heat pump basically means it is a form of moving heat. So whether that's a air conditioner, a hot water service using refrigeration, that's what they're looking at. Air conditioning and heat pump systems incorporating a compressor shall be provided with an isolating switch, which is lockable in accordance with clause 2322, installed adjacent to but not on the unit. So many people still install the isolators on the units. You can't do it. You have not been able to do that for quite a long time. If we want to make sure that isolator isolates all parts of the system, including ancillary equipment such as head units, from the same location. So for split system air conditioning units where the manufacturer requires the air conditioning system to be connected to the electricity supply by means of a plug-in socket at the internal unit, the isolating switch installed at the external unit shall control the socket outlet located at the internal unit. So for air conditioning systems including room heaters incorporating a compressor, so like maybe a box type unit, where the internal unit or units are supplied from a circuit separate to that of the compressor, a warning sign shall be permanently fixed on or adjacent to the compressor isolator, indicating that the isolator does not isolate the ancillary equipment where the internal units or units are not connected by plug-in socket. An independent isolating switch lockable in accordance with 2322 shall also be installed adjacent to each separately supplied internal unit or units. Now, that specific ruling, for some people might go, oh, it doesn't make sense. Like if you're only installing split systems, back-to-back splitties, or multi-head split systems, it doesn't make a lot of sense. But if you're installing like a VRF system where you've got, for example, you might have 7 or 8 outdoor units with multiple indoor units and connected to that. So for example, we've got one at the moment, we've got 36 indoor units on 7 outdoor units, all piped, all with interconnecting BMS cabling basically. All the indoor units, so we just did the refrigeration side and the mechanical side. We didn't do the electrical side, only the control wiring. The electricians or the engineers have actually got a separate circuit for each individual outdoor unit, which is the norm, but they've also got separate circuits for each individual head unit. So there's also isolators for each individual cassette system in the roof, just for maintenance. So the isolating switch may be installed at the switchboard for this, supplying the system if the switchboard is dedicated to the equipment, e.g. an air conditioning plant room. So in this particular project that we're doing, it's not. So they're basically just being fed off general power switchboards. But this clause does not need to apply to unitary window or through-wall air conditioners, nor to heat pump hot water services that are supplied by a plug-in socket outlet installed adjacent to the unit. So if you can unplug the unit and that unit is like an all-in-one unit, you don't have to worry about an isolator because unplugging it deems to satisfy that. So lifts. So 4.2 on page 265. The electrical installation of lifts shall be in accordance with the appropriate requirements of this standard. Lifts covered by this standard include the following: electric lift, electro-hydraulic lifts, goods lifts, motor room lifts, MRLs, or passenger lifts. Lifts shall be installed in accordance with the National Construction Code of Australia or the New Zealand Building Code. Lifts that are installed as emergency lifts shall comply with the additional requirements for safety services in clause 7.2. Note, regulatory authorities may have additional requirements. Lift supply arrangement. Lifts shall be supplied by a dedicated circuit, so you can't pinch or share power for a lift. Labelling. Lift circuits shall be clearly identified by contrasting colouring or other suitable means in accordance with 2334, such as warning: lift circuit, do not switch off. Motor roomless lifts classified as lifts due to their design have no need for a traditional lift motor room. These styles of lifts that are installed as emergency lifts shall comply with the additional requirements for safety services in clause 7.2. MRL switchboards. An MRL switchboard shall not be located in the lift shaft. So you can't have the switchboard for that motor shaft, that lift motor inside the lift shaft. A switchboard located remote from the main switchboard and dedicated to supplying individual MRL switchboards shall be readily accessible. Switchgear. The protective and control devices of an MRL shall be located in a readily accessible position. And that's it for section 4. So that was a huge one again. Again, it's a huge book. Like, we've got 8 sections followed by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 14, 15, 16, 17, 18. About 18 appendices. So it's a lot of information to sort of absorb. It's tricky as well. I got distracted a few times and ended up we actually went to the park with the kids. Had kids running in and out of the office while I was recording this one, so I apologise if I wasn't concentrating as much as I normally would. But that was section 4, which was huge, absolutely huge. It's really important to, again, have a read of that section for yourself. Really absorb all those diagrams and also the tables that we've spoken about. It'll really give you a huge grasp of selection and installation of the electrical equipment. It's not the be-all and end-all, but it's a very good entry point for selecting and installation of electrical equipment. So thanks for hanging in there with me, guys. I know that was a long one. If you've made it this far, thank you very much. Please, if you could share this podcast with your colleagues at work, your mates at trade school, or anybody that you know might be looking to get into the electrical industry, it would certainly help me out. Like, I do this in my own time. I don't get any money for these podcasts. It would be nice, but I don't. So again, if we're going to move on to section 5 next week, which again, that'll be a pretty big one too, which is earthing arrangement and earthing conductors. It's pretty important to get the earthing of your electrical system right and understand why we do what we do. So you've been listening to What's Up, Mate, a podcast for electrical and air conditioning technicians in Australia. Have a great week out there, guys and girls. It's getting warm. Summer's just around the corner, so look after yourselves, and I'll speak to you all next week. Thank you.